Hello everyone, welcome to Roman Just Codes. I'm Roman, and in this episode I'll continue building our Flicky home automation app. This time we'll be focusing on fleshing out the homepage, where we land our users when they enter the app. They can view at a glance the devices that they'll be managing, their energy consumption, and quick actions for how to add new devices, etc. Using the existing core widgets, I'll create some custom widgets that I'll use to illustrate my point that sometimes you can roll out your own custom widgets instead of installing a separate package or library. Make sure to catch the previous videos in the series so you can catch up, or grab the link to the repo from the description for the full project. Let's get cooking. In the previous video, we left off building the navigation elements for this app, as well as creating some placeholder pages for our home, rooms, devices, and settings. Let's build up on our placeholder homepage widget and build it fully. This is what we will achieve in this video. We'll build a homepage with a header section, a scrollable list of cards to manage quick actions, and a simple custom bar graph just by reusing the core widgets available. We'll tackle both themes simultaneously, as well as set the stage for our responsive strategy, since we want to be able to display this appropriately on larger screens as well. Go to the existing homepage.dart widget and replace the contents of the build method by setting a flex widget as the root widget, with its children aligned vertically and left aligned. Add as the first child an expanded widget. Let's start building the header portion of this page. So use a flex child, also with its children laid out vertically. We'll be laying out the labels vertically regardless, so you can use a column widget straight up, with its children left aligned as well. Apply the corresponding text styles by pulling from the text theme available in the theme.of context accordingly. Assign the corresponding color from the color scheme. For the top label, the secondary color. For the bottom label, the primary color. Wrap the existing column in a row so we can force its contents to be left aligned. This is an old trick. Apply some padding around it. You can reuse existing padding values and tweak as needed using the copy with method for reusability. Looking good so far. Let's throw some staggered animations on it while we're at it. As is customary, extract portions of your widget hierarchy into separate widgets. In my case, I'll extract the whole header portion into a separate widget I'll call Home Page Header. Do the appropriate cleanup and arrangements to make it work as before. Flawless execution. Moving on, let's add a bit of space between our newly created header and our next widget. Use one of the pre-canned spacing widgets we created earlier. Let's flesh out one of the tile cards. Start with a column with an arbitrary fixed height. I'm going with 150 pixels. I want to set some solid constraints for my list of tile widgets, so that's what I'm going with. Before I even go any further, let me follow the practice of extracting this into a separate widget I'll call Home Tile Options Panel. Clean up and import as needed. Right away, I'll make it into a consumer widget since I'll be reading the corresponding providers from within. Next, let's create the relevant models that will hydrate this portion of the UI. I'll create a model that will represent each home tile option. Hey, let's call it just that, home tile option.dart. It will hold an icon, a label, and an option that I don't have yet. let me create an enum that represents each of the available options. Add device, manage devices, and test connection. Back on the Poto object, add the new enum type. Create the repository that will hold the data for the available options in this app. I'll hard code it in here for now, but this could come from a configuration file, from an API, from Firebase, what have you. As long as you decouple it from the business logic and UI, it's all good. Create a Riverpod provider that will encapsulate its retrieval, but add the file that will hold all landing-related providers as such. Start with a simple provider that returns an instance of the home tile options repository. Remember, you could replace this by a mocked implementation for mocking and testing purposes. Right now, our mock is our implementation, but you get the idea. Create a view model called Home Tile Options View Model, which will manage the home tile items for our UI, keep track of which one is selected, notify the UI of changes, etc. For that, let's create a method called onTileSelected, which takes the currently selected home tile option instance, which will execute the corresponding logic based on its corresponding home tile option enum value. That way, you encapsulate all the business logic related to the tile selection here, as expected. Create a provider type stateNotifier provider that encapsulates the view model logic, fetches the default data that powers it, and returns an instance with those defaults already preset. Let's go to our UI, the Home Tile Options panel, and start consuming this provider, shall we? Use the ref instance injected to watch this provider and listen for changes. Populate the list view's children with the values obtained from the Home Tile Options VM provider. We start seeing stuff. Good sign that things are working as expected. Let's continue fleshing out the look and feel of our home tiles. This is nothing but a column with an icon and a label underneath it and a small gap in between them. The column is wrapped inside a container with the appropriate decoration to make it look like a tile, as well as some amount of margin to give it room to breathe. You'll see, no need for extra libraries or packages. I'll use an inkwell here, both to get the material inkwell effect as well as the on-tap event. Remember that for the inkwell to work, it must have a material widget as an ancestor, since this is where the ink reactions are actually painted. Add some border radius to give it that rounded look. Yup, you gotta do some clipping at the material widget level, so use the available clip behavior property. Once my tiles are fully built, guess what I'll do with this chunk of widget structure? You guessed right, extract it as a separate widget. You're getting the hang of it. Good for you. I'll call it homepage tile, pass a tile instance to it, and provide its own on-tap event in order to encapsulate the tapping functionality inside of it. Do the necessary plumbing to make it work as usual, plus adding the two required parameters, a home tile option instance and a function instance to bubble up the tapping event, which will serve as some sort of callback. You can pass the currently selected tile through the callback if you want as such. In the onTap callback, leverage the Home Tile Options VM provider instance to access the available method onTileSelected, passing the currently selected tile option, which internally will handle the appropriate action accordingly. Wait, I'm not done here yet. Let me add some padding on the list view because I see it a bit tight on the left side. Testing of both themes as a sanity check. Looking really good. If you want, you can leave it up to here, but I feel I kind of want a subheader here that describes what these styles are. Quick actions to be executed by the user. I promise I'll be quick. Look, it will be just a row consistent of an icon and a text widget with some gaps around it. I'll animate it to continue with my motion design strategy. See, I knew you'd like it, and somehow it gives it a nice touch and adds more context to this region, don't you think? With that, we're done with the top portion of this UI. Let's proceed right away with the bottom portion of it. Hope you'll like it, so stick around for the second part of this video. For the second part of this video, we'll build out the bottom half of our homepage, dealing with a minimalist visualization widget to display the collective energy consumption of our devices. This is not required, or you can opt to download a package for this. I just want to show you how easy it would be to do if you want to do it, just using core widgets already available. I'll start by creating a widget called Energy Consumption Panel right off the gate, so create its corresponding file for it. This panel will display each individual value as a simple rounded corner bar, so let's account for the model that will hydrate its UI. Create a Dart model called Energy Consumption Value. I'll add 3 properties, a string to display the corresponding day, the actual value, and a boolean flag called above threshold to show it in a different color if my energy consumption goes above a predefined threshold. Don't make too much of it for now. This is just building the foundation for future implementation, but stick with me for a bit. We're gonna need a repository entity that will supply the values, whether from a service, Firebase, a local DB, or what have you. We'll come back to it. First, create a model that will encapsulate the list of values to supply to our energy consumption UI panel. We'll call it just that, energy consumption. It will simply hold a list of energy consumption values, plain and simple. Our corresponding repository will have a method called getEnergyConsumption, which returns an instance of our newly created energy consumption. I can even fast forward this part, as you can do whatever you want to populate the energy values. For now, I'll mock them using just some randomly generated values and thresholds. Remember, these could come from the actual energy consumption value collected from your smart devices, which you can store on a local DB, share preferences, whatever serves your purposes. There's nothing special about this logic, just generating random values between a range, setting an arbitrary threshold, and returning a list of energy consumption value instances. Create a provider that encapsulates an instance of our energy consumption repository, as well as a provider that encapsulates the retrieval of the energy consumption. This extra level of abstraction is what facilitates testing and mocking in RiverPod, which you can swap between a mocked version or the actual implementation without affecting the rest of the layers, keeping things decoupled and clean. Back on the UI for our energy consumption panel, start by making it a consumer widget as well as reading the data from the providers and repositories just created. Let's flesh out the core structure. We'll lay things out vertically, a header followed by the list of energy consumption values as a horizontally scrollable list of columns. Each column will show a value and a label at the bottom. If the value goes above the preset threshold, it will show green, otherwise it will have some default color. Let's proceed. Start with a column widget. For the header, use a row with an icon, a small gap, and a text widget. Apply a decent text style, bold its text, and use the primary color from the theme. Depending on the theme applied, the right color will show. Make some adjustments accordingly. Wrap the root column widget in an expanded widget. I want this panel to occupy most of the real estate in this page widget. But then inside the energy consumption panel, I want the list of columns to occupy most of the space within itself. So I'll do another expanded widget under the header section. I'll add a list view builder since I want it as a horizontally scrollable list, and I also want to optimize the items that get rendered within this list. I've done quite a bit of coding. Let's test that at least I can see the energy consumption values in a simple text widget. We can see values. True, this is not very appealing. Let's create a better visualization for it. Create a separate widget to hold the energy consumption bar. I'll call it energy consumption column.dart, feeding into it the corresponding energy consumption value instance in the iteration. Back on the energy consumption panel, replace our placeholder label by our newly created widget. In our energy consumption column widget, add a text widget again, preceded by a placeholder spacer widget. This is just to represent the space the main content will hold. Spacer is nothing more than an expanded widget with a flex of 1. Let's build the energy consumption value bar, or the energy bar. Look how simple, a container widget with a small margin all around, a predefined width as I want some consistency. Some decoration, using the secondary color from the corresponding theme for the background, a bit of border to make it look round, and as a child, yet another container with similar styling to represent the actual value fed to it. But how should I do it? One way is to use the layout builder. That way we know what our constraints are coming from our parent container widget. That way we know how much space we have to work with. I'll use the constraints.max width instead of hard coding it to 35. And as the height of the energy consumption value, I'll use the constraints.max height to know how much space I have height-wise. Then normalize it as a value between 0 and 100 from the provided value, and no need for hard coding. I want my values to be a representation between 0 and 100% consumption, something like that. Another way to do it would be using a fractionally sized box, which is a widget that sizes its child to a fraction of the total available space. It's good to have options. Apply the necessary decoration for the color and border radius. So if the value is above threshold, apply the primary color in the theme with some opacity. Otherwise, use a tertiary color in the scheme. Play with the values until you're good with it. Wow, even at this point it's looking pretty slick. Let's show the value of the energy consumption. Simply add a text widget as a child of the container. And that is why I added this padding earlier, because I knew this was coming. As usual, let's add some pizzazz to the value columns by animating them as they render when they come into view, using a scale XY and a fade-in animation with the proper parameters. To wrap this piece up, animate all the columns as they render inside the list view's viewport for the cherry on top. Since we are in a roll, let's animate the header portion of this panel using a sliding transition that matches the top header animation as well. I like to add small delays here and there to pace things and so things don't all come out at the same time. You can continue tweaking and sprucing up more, but I'll add one more animation to the home tiles doing the same approach. Animating them using a staggered animation, also with a scaling and fading transition as they come in. And right in front of your eyes, I was able to build this minimalist visualization for the energy consumption panel, as well as build the UI for my homepage. In the next video, we'll jump right into the devices page, adding devices using a simple input form, so we'll dive into validating fields and populating our models from input controls and the overall managing of our smart devices so we can control them. See you on the next video. Hey there, I am Roman from Roman Just Codes. I hope that you found the content of this video very useful, and if you did, make sure to like it and subscribe to this channel. You know subscribing to this channel is free, right? Thank you so much for watching.